Hi, my name is Celestia and I decided to become an expert in the Forces in Motion Basics Lab via phet.colorado.edu. This simulation lab covers force, motion, friction, speed, Newton's first and second laws, and kinematics somewhat. The first simulation covers net force, or the sum of vector quantities that act upon an object. To get a full picture, I turned on the sum of forces, the values in newtons, and speed/velocity in meters per second. These little guys represent forces of different magnitudes which you can add by dragging or remove in the same way. Opposing forces can be thought of as negative and positive values, or as if this is a y-plane and this is an x-plane, and here's the negative and here's the positive. If both sides start off with the little guides who exude equal forces, or both 100, they essentially cancel out and the net force is 0. These are balanced forces, and this shows how an object will stay at rest with no net force. Unbalanced forces are forces acting on an object that don't cancel, and the net force is not 0, which is depicted here. This shows how an object will accelerate if a net force acts upon it. You can also see that if I start with balanced forces, but then impose a net force on the object, that object's motion, or lack thereof, will continue forever unless it is acted upon by a net force. For this motion simulation, you have force, values, masses, speed in meters per second, and a stopwatch. You can remove or add objects of varying masses by dragging them to and from. You can apply varying forces by dragging this to and from as well. If I apply all of these and run it for 5 seconds with the guy applying 100 newtons of force upon this 50 kilogram box, you can even use kinematics or Newton's second law to determine acceleration and displacement. And you can use this for slower increments of time. When you run it again but the object's mass is 250 kilograms, the acceleration and displacement lessen greatly, showing an obvious correlation between force, mass, and acceleration. The third simulation covers friction, or a force which is the result of interactions between rough microscopic surfaces. This simulation has everything that the last one did, with the re-addition of the sum of forces and a bar in which you can apply varying degrees of friction, which you can see right here. You can see how it opposes the applied force and affects the net force. And the more frictional force, the greater resistance to the applied force. The fourth simulation shows the relationship between acceleration, depicted here in a bar in meters per second squared, and frictional force. When frictional force fully meets acceleration, the forces are balanced and there is no movement. But you can see that when you overwhelm it, you gain acceleration. Thank you so much for watching my video, and if you would like to try the simulation out for yourself, I'll have it linked in the subscription. Have a great day.